So another example here, lads. Look, I guess this is another chain rule, but in actual fact, this one here, if we aim to simplify that top line first, so x squared minus 1, we ever see a difference of squares, let's bring it into play over the square root of x minus 1. Yeah. Now, don't forget that root 8 is equal to the square root of 4 times the square root of 2. So if we have two terms both under a square root sign, well, we can separate those, can't we? That's x minus 1 times the square root of x plus 1 over the square root of x minus 1. So that actually simplifies to the square root of x plus 1. So in actual fact, if we come across a bit, g of x can be simplified to x plus 1 to the half. Yeah? So the derivative of that is equal to, remember, bring the power out the front. We just treat x plus 1 as if it was an x term. Subtract 1 from the power and then times by the derivative of whatever's inside the bracket, which in this case is just 1. So then the actual derivative, just to write it a bit nicer, 1 over 2 square root x plus 1. Okay, so if we can simplify the expression first, we should aim to do that. All right, well, let's pause there. Let's go off on 9F and work through those, but I'm going to roll into now differentiating exponential functions. So we've had a look at our chain rule, and we're going to make use of that chain rule throughout each of these next set of examples. The first of the derivatives that we're going to look at in terms of the different functions is our exponential function. So it's one of those unique functions, the derivative, the exponential function, is that in that the derivative of the function is the same as the function itself. So the derivative of e to the x is in fact e to the x. Okay, so the more general form, if we have e to the 2x or e to the 6x or e to the 3x, the derivative of that is the k term comes out the front and it just stays the same. All right, so what we're saying there is if y equals some e to the 2x, well then y dashed is equal to, power comes out the front. Where we have been taking 1 from the power, we don't do that anymore, okay? We keep it the same. So this rule is on your formula sheet, all right? This next rule is one that we should try to remember. That's just a little application of the chain rule, all right? So remember we were talking about how with our chain rule, if I have a function, what we're saying is if we have an exponential function, to work out the derivative of that exponential function, we differentiate the power. So the derivative of 2x is just 2e, and we don't touch the power at the top. All right. So in the case where it's just a 2x, 3x, 4x, etc., the derivative, or a kx, just happens to be that k term. If we have a more complicated expression in the power, okay, look at some of these down here at f and e, well then we differentiate the power, bring it out the front, leave the power the same. So f dash of x is equal to, differentiate the power, so the derivative of 2x is 2. 2 times 3e, leave the power the same. So that's just 6e to the 2x. F of x equals, so f dash of x is equal to, differentiate the power, or the derivative of negative 2x plus 3 is just negative 2. So it doesn't matter that there was an extra term. Negative 2 comes out the front, times 4e, don't touch the power. So that's negative 8e to the negative 2x plus 3. Multiple terms again. F dash of x is equal to, the derivative of the power is 2. 2 times 3e to the 2x plus derivative of negative x is negative 1. Negative 1 times 2e to the minus x. Well, I guess minus derivative of e to the minus 2x is negative 2. So negative 2 minus 2 times 4 e to the minus 2x. Powers didn't change. 2 by 3 is 6e to the 2x minus 2e to the minus x plus 8e to the minus 2x. Yeah? And we just keep the same process. F dash of x is equal to, what's the derivative of 2 minus x on 4? Well, that's a quarter of x, so it's minus a quarter. So it's 2 times negative a quarter. E to the 2 minus x on 4, which is equal to negative a half e to the 2 minus x on 4. All right? More complicated looking expression up there, but it's the same. F dash of x is equal to, the derivative of that power is 2x minus 2 times e to the x squared minus 2x minus 3. Finally, f dash of x is equal to, what's the derivative of that? So now we've got a little chain rule in here. So the first question is, what's the derivative of 2x squared minus 3x to the 2? So the derivative of that is 2 comes out the front, 2x squared minus 3x, take 1 from the power, multiply by the derivative of the inside, which is 4x minus 3. Yeah? So that's the derivative of that expression. So that comes out the front. So I'm just going to bring that 2 into this bracket here. So I'm going to write, yeah, I may as well, 8x minus 6 in bracket times 2x squared minus 3x e to the, I'm going to run out of room, 2x squared minus 3x squared. Yeah? So we can multiply these together if we wish, but I don't think we gain a real lot. All right? So key is exponential function, e to the function, it doesn't matter whether it's a kx or a 2x squared minus 3x. Derivative of whatever that power is comes out the front, and then we leave the power unchanged. Go ahead and practice.